In this video, I will talk about some trigonometric limits, which you see on the left-hand side. Limit as x approaches 0, sine x is 0. Limit of cosine x as x approaches 0 is 1. And limit tangent x as x approaches 0 is 0. It's based on the graphs of these three trigonometric functions, y equals sine x, y equals cosine x, and y equals tangent x. Also, we have two special trigonometric limits, which we use often in calculus, and it's limit as t approaches 0, sine t over t, which is 1, and limit as t approaches 0, 1 minus cosine t quantity over t equals 0. So we will use all these 5 limits today in this presentation. So the first question I want to discuss is, let's look at this. We have this expression initially. Limit as x approaches 0 of the quotient, the numerator sine x times the quantity 1 minus cosine x divided by the quantity x squared. So we're trying to figure out what happens if we substitute x with 0. We get sine 0, 0, 1 minus cosine 0, 1 minus 1, 0. So we have 0 times 0 in numerator and 0 squared in denominator. We cannot cancel zeros like this. When you have 0 over 0 is indeterminate form, and you have to do something differently. And that's what we need to do. So when we look at this side, we can see that we broke this rational expression as sine x divided by x, and then one more x left in denominator, 1 minus cosine x divided by x. And I also use the property of the limits, that limit of a product equals to the product of the limits. So now what is limit here? Let's look back at our first slide, and this is the special trigonometric limit with a value of 1. So this limit equals 1. What is this limit? It is second trigonometric limit, and here you have the value of 0. So we have 0 for this limit, and we have 1 times 0 is 0. That's how you work on this type of expressions. Next example. Limit as x approaches 0, sine squared x over x. The same idea. We plug in 0 in place of x, and we got sine squared 0, which is 0 over 0. 0 over 0 is indeterminate form, so we cannot say that it's a number. We don't know what it is. We need to continue in different direction, and the direction will be look at sine squared x as sine x times sine x, and then break it again into two limits. Limit as x approaches 0, sine x over x. You can see that there was sine squared, so one sine is here, so one more sine from sine squared left over here. And now we just look at the first slide. So we have the first limit is 1 because of this expression, and this is 1, and the limit of sine x as x approaches 0 is 0. So when you look at this, that is 0. So again, we have a situation 1 times 0, and it's 0. Next example, limit as x approaches 0 of the quotient cosine x times tangent x divided by x. It's no more sine x here explicitly, but we can apply the technique which calls dividing out, because if you plug in 0 here, you again get in the same situation 0 over 0. So what is tangent? Tangent is sine over cosine. So when you replace tangent by sine over cosine, you might see that you can cancel cosine in numerator and cosine in denominator, and you will be left with a limit as x approaches 0 sine x over x. And this limit, as we remember, is 1. So the answer to this is 1. And one more example with these trigonometric functions. What if we have limit as x approaches 0 tangent squared x over x? Again, if you plug in 0, you get tangent squared of 0 is 0 over 0. Not good. So we're looking at the tangent as sine over cosine, but we don't need sine squared together. We can break sine squared into sine x times sine x, and one sine from tangent squared I have here. Another sine I have here over cosine squared, because tangent squared is sine squared over cosine squared. So one sine is here with this x, and another sine with the cosine squared x left from tangent squared. So now we break into two limits. So limit as x approaches 0 sine x over x is 1, and limit as x approaches 0 sine x over cosine squared will be 0, because we just plug in x equals 0, 0 over 1 squared, which is 0 over 1, 0. So we have again 1 times 0 is 0. That's all for today. Thank you for your time.